Alright, in this class we'll be looking at alkane, the family of alkane. Well, the first thing you know is that the alkane family has a general molecular formula of CnH2n plus 2. That is the general molecular formula for alkane. And alkane has no functional group. If you look at an alkane, you'll understand that the arrangement of alkane is from C1 to C10. That is for your level. Although you can have C15, C20, C30. Okay, what I mean by C1 to C10 is carbon 1 to carbon 10. That is what the curriculum of your exam will cover in this period or this semester. Meanwhile, we need to know that you can pick any of the carbon from C1 to C10. Let's say you're picking carbon 4. If you're picking carbon 4, okay, you're going to be having that what number of hydrogen will be needed to complete the carbon 4. Already, the N represents the number of carbon, and then the 2 is multiplied with the N. So what I'm going to have is 2 times by 4, and then I'm going to add plus 2. Now the value I'm going to have here is 8 plus 2, that is going to give me 10. So I have that H will be equal to 10. Now, this carbon 4 is called butane. This is called butane. Well, if it is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, carbon 8, carbon 9, carbon 10. Carbon 1 is methane, carbon 2 is ethane, carbon 3 is propane, carbon 4 is butane, carbon 5 is pentane, carbon 6 is hexane, carbon 7 is heptane, carbon 8 is octane, carbon 9 is nonane, carbon 10 is decane. Alright, now these are what you need to know. Well, if you want to know how to name organic compound under the families of alkane, we have a video on that. You can check out our YouTube channel for IUPAC nomenclature of alkane. Now, we want to go to the method of preparation of alkane. So we have the next thing is the method of preparation. The method of preparation. The first one is called dehalogenation. The halogenation of halogenoalkane. The halogenation of halogenoalkane. The halogenation of halogenoalkane. Number two is from alkene. So we can produce alkane from alkene. That is carbon-carbon double bond family alkane. And then we can produce alkane from decarboxylation. Decarboxylation. In this decarboxylation, we are going to decarbonize the salt of alkanoic acid in that procedure. And then the next one is from carbonyl compound. From carbonyl, okay, let me give you well. From carbonyl compound. Alright, that process is called Clemmensen reduction. It's known as Clemmensen reduction. Alright, now finally we're going to have the addition of water to aluminium carbide. So this is the 5 major methods of producing alkane. Well, if you are writing JAM exam, UTME exam in West Africa, Nigeria, this is what you'll be looking at. You'll be looking at the carboxylation method. That's what they have for you. You'll be looking at addition of water to aluminium compound. That's what they have for you. But if you if you're writing exam that is not UTME exam or JAM exam or any other extra exam, you're required to know all these processes. Meanwhile, for the JAM, West African Examination, this is what you're required to do: the carboxylation and the addition of water to aluminium, but aluminum carbide. But meanwhile, you still need to know this one in case of necessity. Now let's look at the first method. The first method is from the halogenation of halogenoalkane. Now, an halogenoalkane is an alkane is from the haloalkane group. Haloalkane group are the alkane that has halogen in it. Now the halogen is fluorine, bromine, iodine, and the rest. Okay? That is fluorine, chlorine, bromine, iodine. Fluorine, chlorine, bromine, iodine. Alright. Now the CH3, CH2, CH2, iodine. Now this is iodo-propane. Iodo-propane. Now we're going to use a reagent. Very important to know the reagent to be used. Let me show you how the questions will come out, or the form the questions will appear. Now, the reagent to be used here is the magnesium amalgam. Whenever you hear magnesium amalgam, that is magnesium in mercury. When you hear zinc amalgam, that is zinc in mercury. When you hear sodium amalgam, that is sodium in mercury. Amalgamated sodium. This one is amalgamated magnesium. Okay, now amalgamated magnesium and ethanol. Okay, now when you use this reagent, you're certainly going to produce a propane. You're going to have a propane. Okay, CH3, CH2, CH3. Now you're going to have two. That's what you're going to have. All right. Okay, you're going to have plus iodide, hydrogen iodide here. All right, so this is what you're going to have for the first reaction. Let's do one more reaction. Now, you ask the question, how do we use bromoalkane? Maybe we have bromopropane or chloropropane. It's possible. But meanwhile, the commonly used halogenoalkane is the iodo-halogenoalkane. And for you to use the chloroalkane or the bromoalkane, you need another reagent, which is not the magnesium amalgam in ethanol. But for the sake of safety, it is advisable that you use iodoalkane, because if you use fluoroalkane, it's explosive. Maybe you will not come back alive. Okay, so let's go back to the board. So we have CH3, and then we have CH2, and then we have CH2, and then we also have CH2, and then we have iodine. So this is iodobutane. This is iodobutane. Well, if you don't know how to name compound, we have a video for that. Check out for that so you can know what we're seeing. This is iodobutane. This is iodopropane, and then it gives us propane. Okay, this is iodobutane, and then it gives me, remember, the magnesium amalgam and CH05, which is ethanol. Okay, it's going to give me butane, C4H10, plus hydrogen iodide. Okay, now, if you are going to asking or going to write an exam, for instance, look at how the questions will come, or how the questions is going to be set. Now, look at this. They'll give you CH3, then CH2, and then CH2, iodine. And then over here, they say what is X and Y, and then what is Z. Okay, now you are asked to give me the answer to X, Y, and Z in a preparation of alkane method using the halogenation of halogenoalkane. Well, the X and Y, you know that X should be the magnesium and mangan. And you know that Y should be the ethanol. And you know that Z should be the propane, which is C3H8. So that's how to get the answer to it. Sometimes they'll provide you with magnesium and mangan, ethanol and propane, and ask you to supply the product, not the product, the templates where you got these answers from. Alright, now let's go back to the board. Now let's say we are using the second method, which is from arcade. Now, from arcade, now if you're writing UTLE, you should also pay attention to this. I think there's a question from this that comes out. Now from arcade, you have CH3, and you have CH double bond, CH2. Now, you should pay attention to the catalyst that is used to promulgate the reaction. Now that you have that, you need to know that you need brother nickel. So brother nickel will be there at about 25 degrees Celsius and at about 10 atm. Okay? Now, this condition is important to promulgate the production of alkane from alkene. Well, I think I made a mistake here. Let me add something. Let's rewrite CH3, CH, and then CH2, double bond. Now we're going to have 2 hydrogen. Alright, 2 hydrogen. Because this 2 hydrogen has to come together, because one of the hydrogen will be in this bond, one of the hydrogen will be in this bond, so as to make the complete alkane. Now, but this condition must be present for the promulgation of the reaction. So that we're going to have this hydrogen will jump into here, this hydrogen will jump into here, and we're going to have CH3, one here, CH2, one here, CH3. So this is the name of this guy is propan 1N. If you don't know how to name compound, check out the video. I say again, propan 1N. Now, you know that the propan 1N having 2 hydrogen, and in this condition, you're going to have propane. That's all. Now, listen to me. They are going to exclude this and ask you to supply this. They may exclude this and ask you to supply this. They might exclude this and ask you to supply it. So anyone, you should be able to take note of the reagents, the reactants, the reagent or condition of promulgation, and finally the product. Now let's go to the next one. The next one we have is from the carboxylation of a salt, known as alkanoic salt. Well, how do we get alkanoic salt? This is not a video. This explanation of how to get alkanoic salt is not for this class. Very fun class. But I'm going to use an alkanoic salt here. Now we have the carboxylation. So, what is the carboxylation? Now you know that we need a salt, a particular salt, which is alkanoic salt. Now, that salt can be sodium ethanoate. Now, we have CH3, CO, let me stretch it. Then we have CH2, and then we have CO, sodium. Now, this is called sodium propanoate. This is called sodium propanoate. Well, let me help you a little. How do we get sodium propanoate? Okay, now, what if you react an alkanoic salt with sodium hydroxide? Let's say this is alkanoic acid, alkanoic acid, then you have CH2, let's follow this form, and COH. This is a propanoic acid. There's a propanoic acid. If you react it with sodium hydroxide, okay? Now what you're going to have, this guy will move here, will move to this place. Now, this guy will move here, this guy will go and form water. You're going to have water first, and then after you have water, then you have this my formula, CH3, CH2, COO, and A. So this is called sodium propanoate. What is propanoate? 1, 2, 3. 3 is propanoate. Now, this is is an alkaloid salt. Okay, now the alkaloid salt here is sodium propionate. Okay, sodium propionate. Now, this one is not for this class. We can check it out in another class. Okay, all right. Now, all of that. What is the reagent to be used? That's another thing to ask ourselves. Now, the reagent to be used is soda lime. Soda lime. Now, the soda lime is a combination of sodium hydroxide plus calcium hydroxide. So, how am I going to use this now? Should we bring in the two into this place, or should we bring just one into this place? Now, what we're going to do is that let's just bring in the two into this place, or we'll bring one of them. So we have sodium hydroxide and we have calcium hydroxide. So when we have these two, definitely we are going to produce alkane, which is a propane. So we have CH3, CH2, CH3. So this is a propane. Alright, this is a propane. Now, what will be the next product? Now let's say this will become sodium 2CO3. Now, that doesn't mean that because I use sodium triazocarbonate, doesn't mean it must also always be sodium triazocarbonate. It can be calcium triazocarbonate anyhow. But the soda lime is a combination of these two. Now, what the question should be is that they can take away this one and ask you to supply X and Y. They might take away any of those and ask you to supply the answer. Now, I want to give you an assignment now. Just one assignment, then you can do that and give us the answer on the comment section. Let's say we have CH3. Okay. Let me not. Can you give us? Okay. Can you give us the products that will be formed when sodium butanoate is combined with soda lime? Alright, give me the product that will form when sodium butanoate is combined with soda lime. Alright, let's go to the next method of formation of alkane, and I think that is from clemency reduction, from carbonyl compound. Okay, from carbonyl compound, which is known as clemency reduction. Well, if you are going to look at clemency reduction, that will be in your college, that is in university level, in your college level, in higher standard examination, even the one of the halogenation of halogen alkane, that is for standard exam. But meanwhile, you should know that it does not hurt to know. Now, for clemency reduction, we can be using the alkanol. We can be using the alkanol, and we'll use a reagent. And that reagent is zinc amalgam, and conc HCl. Zinc amalgam and concentrated HCl. If you carry concentrated HCl, be careful you don't get burned. So zinc amalgam and conc HCl. Now we have CH3, and then we have O here, we have CH3, and then we have the reagent there. We have a reagent. Okay, and you know you're going to add plus 2H, and then we have the reagent, this reagent, zinc amalgam and conc HCl. Alright, now what I'm going to have is that this is called, what's the name of this guy? Should I tell you? I'll tell you. So this is propanol. This is propanol. But you can call it accurately and say propan 2O. Okay? This is propan 2O. So this now will form propane. Okay? CH2 and then CH3. So this is what we got for you. I tell you again, they will take away any of those and ask you to supply the answer, or even ask you to give us a list of method of preparation of alkane and the explanation. So anyone that gives you, you'll be able to answer. Alright, let's do the last method of preparation, which is addition of water to aluminum carbide. So this is aluminum carbide now. Now let's add 12 molecules of H2O. So what we're going to have is aluminum hydroxide, 4 aluminum hydroxide, okay, plus 3CH4. So this is what we have. When you add water to aluminum carbide, you're going to have aluminum hydroxide, and then this maintain. Now this structure or this method, you should note it if you're writing UTME exam. Now let's go to properties of alkane. Under the properties of alkane, we have physical properties, which is the first one we deal with. Physical properties, you can write that now if you're writing. The physical properties of alkane is one is an odorless and colorless gas. Now, why do you call it a gas? Well, not all alkane are gas at room temperature. Let me show you. If you go from carbon 1 to carbon 4, these ones are gases at room temperature. If you go from carbon 5 to carbon 17, these ones are liquid. Okay, colorless gas, also colorless liquid. This one is liquid at room temperature. If you go from carbon 18 to ETC, to X, this one is solid wax or waxy solid at room temperature. They are less denser than air. Okay, they are less denser than air. That's another physical property. Another physical property is that the melting point and the boiling point increase as the carbon atom increase. That means that carbon 1, carbon 1, carbon 4, carbon 5, carbon 17. Now, from these 4, which of them has the highest melting and boiling point? It is carbon 17. Okay? Because the more the carbon atom, the more the melting and the boiling point increase. Now, branch chain reduce melting and boiling point. When you have branch chain, it reduces the surface area of that molecule and then reduce the melting and boiling point. Take it again. The higher the carbon, the higher the melting and boiling point. Branch chain. Let's just say we have CH3, we have CH3, we have CH3, we have CH3, and then we have CH3, CH2, 4, CH3. Now, which one has the highest boiling point? It is that. Okay? This guy has highest boiling point. This branch chain reduce the boiling point. Anyway, now the next thing in line of the physical property is less denser than air. So this is what we got from you in the physical property. The chemical properties now. Well, pay attention to the chemical properties because I think that's all we're going to do for you. Now the chemical properties and the chemical properties, not later now. Chemical properties. Now, the chemical properties, okay? The chemical properties is one, combustion. Now, combustion. If you burn alkane, you have carbon dioxide and water. Now, let's say we are going to burn, let's say methane, and then in the presence of oxygen, okay? Now, you're going to have CO2 plus 2H2O. Now, meanwhile, if the amount of air is, you burn an organic compound in an atmosphere that you have a large quantity of air supplied with oxygen, it will produce carbon dioxide and H2. But if the amount of air, the amount of oxygen that is available is limited, and you are burning an alkane or burning an organic compound, you have carbon monoxide and water. It's just like you go into your room, you take a plastic, your plastic chair, and then you go into your, lock up the window, lock up the door, light the plastic chair, it will be dropping water, but carbon monoxide will produce. You will choke yourself and you might not survive. Don't do that at all. So now, all we're going to have will become carbon dioxide and water. Now, meanwhile, another reaction that is very crucial is called halogenation. Some textbook call this chlorination, addition of chlorine. So we have halogenation, but I love to call it halogenation. Halogenation is to add halogen to an alkane by a process known as the substitution reaction. You know we have substitution reaction, we have addition reaction. Alkane is saturated, so you can take away an hydrogen atom from it. So let's say I have CH4 and then plus chlorine. Now, this thing must happen at a temperature of about 275 to 400 degrees Celsius, and in the presence of sunlight, ultraviolet sunlight. That's in the day, daylight, sunlight. Now, this guy is going to give me a chlorometane. It's going to give me a chlorometane plus HCl. Now, if I take this chlorometane and then add another chlorine molecule, I'm going to have dichlorometane, okay, plus HCl. If I take the dichlorometane and add another chlorine molecule, I'm going to have trichlorometane, okay, correct, plus HCl. If I take the trichlorometane and add another chlorine molecule, I'm going to have tetrachlorometane plus what? HCl. Now, this is an exothermic reaction. It's an exothermic reaction. I'll show you why. If you carry out this reaction, it's an exothermic reaction. Now, if you look at this, the trichlorometane and tetrachlorometane is an important solvent in chemistry. But this guy is used as an anesthesia in surgical operation. Meanwhile, the two of them are very important solvents in chemistry, these two guys. Okay, but this trichlorometane is used as an anesthesia in the hospital. Now, well, this is an endothermic reaction. If you are going to be using bromine and iodine, that one of bromine and iodine is an endothermic reaction because the heat will be given off in this reaction, while that of iodine and bromine, heat will be absorbed in that of the reaction. Now, fluorine, you know, I was talking about fluorine the last time. We talked about production of alkane from halogen alkane. I said, don't try that at all. If you use fluorine, the reaction is vigorous and it is explosive. You might not live to tell the story. Don't try that at all anyway. So if you are using fluorine and you are trying to do halogenation with fluorine, if you are born again, you get to heaven. If you are not born again, you go to hell, as the case may be. Now, this is what we have got for you in this video. And if you have a question, drop it in the comment section. I've already told you how the questions will be structured and what you expected to see in the question. In summary, first of all, you need to know the general molecular formula. After the general molecular formula, know the method of preparation from the halogenation of halogen alkane, from alkene, decarboxylation, from clemency reduction, that is carbonyl compound, and then from addition of water to carbide. And then you look at the physical properties and what is in there, and the chemical properties and what is in there, and the things I've told you before now. So this is what we've done for you. If you have a question, comment in the comment section. We'll attend to this soon. Thank you. Bye for now.